Okie dokie, here we go. May 2013 past paper with some idea of how to go about it. 4 different factors. Let's underline keywords as we do these things. Factors, so things which we can multiply to get into 27. That's 1 and 27. And the other ones are 3 and 9, because 3 9s are 27. 1 27 is 27. Write down 2 different prime numbers between 20 and 40. Okay, so they have to be not divisible by anything else. So 20, 21 divisible by 3, 22 divisible by 2, 23, that's prime. 24 divisible by 2, 25 by 5, 26 by 2, 27 by 3, 28 by 2, 29. There we go, bang. 2 different prime numbers, excellent. Write out the first 4 multiples of 8. 8, 16, 24, 32. So in this question, look, we've had factors and we've had multiples. Let's not mix those 2 up. Okay, choose a square number from the following list. 5 squared is 25. 6 squared is 36. So either of those 2 can go in your answer here. So 5, for example. Okay, question 2. Write 48 as a product of prime factors. Product of prime factors. We remember that product means multiple or multiplication. So 48, here we can use our factor ladders. 48 divides by 2, 24 times. 2 is going to 24 12 times. 2 is going to 12 6 times. 2 is going to 6 3 times. And I do this one, 3 is going to 3 once, just to remind me that when I've got the bottom here, I've finished. So I write 48 is the same as 2 multiplied by 2 multiplied by 2 multiplied by 2. That's 1, 2, 3, 4 2s and a 3. 48 equals 2 times 2 times 2 times 2 times 3. We can also write that as 48 equals 2 to the power 4 times 3. Either of these answers would be acceptable, I should think. What is the lowest common multiple? Okay, well, what are the multiples of these numbers? 6 goes 6, 12, 18, 24, 30, 36, 42, 48, 54, and so on. 12 starts 12, 24, 36, 48, 60, 72, and so on. And 18 goes 18, 36, 54. Well, actually, we don't need to go any further, do we? 36 is in all 3 lists. It is the lowest number that is in all 3 lists, because as you can see, look, we might get another one here shortly. It's the lowest number in all 3 lists. These are the multiples. The lowest common multiple is 36. 36. 2 numbers can be written as a product of primes. A is 2 times 2 times 3 times 5. B is 2 times 3 times 7. What is the highest common factor? Highest common factor is everything which is in both lists. So I've got a 2 times 3 in this list, and I've got 2 times 3 in this list. So 2 times 3, which is 6. So my answer is 6. My methodology is 2 times 3. Good, first page, loads of marks. Well done, you lot. Sets P, Q, and R are defined as follows. So the set P has in it the numbers 1, 2, 3, 4, 5. The set Q only has the numbers 1, 3, 5, and the set R has the number 4. So we have to fill in the blanks here. Q union R. Union means together with. So the stuff that's in Q together with the stuff that's in R would be 1, 3, 5, and 4. So we say 1, 3, 5, 4. It doesn't matter which way you order these numbers, although it would be nice really to put 1, 3, 4, 5 if you are aware enough at the time. Something exists in R. The only thing that we know inside R is 4. Exists in or is an element of, that's what this symbol means, is an element of. Q intersect R. Q intersect R means the stuff that's in Q and is in R. Well, if we look at, here's Q and R, what's in here but also in here? Well, nothing. There's no numbers, no elements, no letters, nothing the same in either of these two sets. So we say this is the empty set. That's a poor drawing. There we go, that's a bit better. The empty set. Fill in the next term in each of these sequences. Helpful to look at the differences when we do these things. How do I get from minus 25 to minus 18? Well, I can add 7. Again, I could add 7, and again, I could add 7. So it makes sense that the next jump would also be adding 7. Careful. So I'm going from minus 4, adding 7 will take me to positive 3. Think of the number line there. 4.34 for the next one, 4.40, 4.46, 4.52. Please don't be put off by the decimals. If this was 434, 440, 446, 452, then we'd be going up by 6s. It's not, however, because it's simply adding 0.06 each time. So the answer will have to also have had 0.06 added, which would take us to 4.58. Next one then. Adding 4 to get to there, adding 4 to get to there, and adding 4 to get to there. Well, that's fair enough. We'll add 4 to get to there. Answer will be 83. Describe sequence C, this one fully in words. Okay, well, it's an adding 4 sequence. Adding 4 to each term. Important bit coming up, comma, first term, 67. If we don't put this bit, it could be any sequence that just adds 4 each time. So 1, 5, 9, 13, etc. Alright, good. Nearly there. Fill in the missing information on each number diagram. 25 divided by 5 gives us 5. 5 multiplied by what? Subtract 3 gives us 37. Well, hang on. That's not so straightforward. But if we take it a step at a time, from this point to this point, I subtract 3 and end up with 37. So if I start with 37 and I add 3, I would need to be at 40. Yeah? So from 37, if I added 3 by reversing that number machine, I'll be at 40. From 40, I'd have to divide by something to get to 5. That something was 8. So actually, if I start from the beginning and 5 and I do multiply by 8, that gets me to 40. Brilliant. 40 take away 3 gets me to 37. Good. So all we needed there was a 8. Next page. Not to scale. So don't start getting out any implements to try and help us out. It has a base of 2 meters, it says in the question, so let's put that on. 2 meters. 2 meters. Technically should have a ruler here. It has a perpendicular height of 50 centimeters. The perpendicular height is the one from the top all the way down to the bottom, which meets the bottom at a right angle. Perpendicular height, 50 centimeters. 2 meters. 50 centimeters. 2 meters. Hang on a second. This is actually 0.5 meters. Because 50 centimeters is half a meter. Cheeky. Right, what's the area of this triangle? Start always by remembering the formula, hopefully. Area equals a half multiplied by the base multiplied by the perpendicular height. So in this case, the area must be a half multiplied by 2 meters multiplied by the height, 0.5 meters. Well, a half times 2 is 1. 1 times 0.5 is simply 0.5. We have used a 2 and a half. Both of those were measured in meters, so it's 0.5, beg your pardon, meters squared. The area is 0.5 meters squared. Now, if you had spotted this, but chosen to convert meters into centimeters, that's fine. You should have 200 written at the bottom, 50 written up here. This would be a bit bigger because you'd be doing half times 200, which would be 100 times 50, so you get 5,000. As long as your answer is then saying in centimeters squared, you'd still get the marks. But in terms of making the numbers easier, it was easier to convert to meters. Okay, area of this shape. This is a compound shape. It is several shapes stuck together. So just choose any shapes that you want to chop it into, really. I think probably most easy is this one here. So if I make a really obvious chop there, sorry, the black pen is unhelpful at this point. Really obvious chop here. Right, this side is 7 and this side is 5. So this side must be 2 centimeters. That's also, on this side is 6 centimeters. That's going to be the same length as this. So this is also 2 centimeters, which means this must be 4 centimeters. It does look like this one's being done to scale, which is helpful. I've now got 3 triangles, rectangles, A, B, and C. Area of any rectangle is the base times height. Base times height. So for rectangle A, the base is 3, height is 7. 3 times 7 makes 21. The area of B will be the base times the height. The base in this one is 3 and the height is 2. 3 times 2 is 6. And for C, the area is the base times the height. The base is 3, the height is 6. 3 multiplied by 6 is 18. Total area of this shape, therefore, will be 21 plus 6 plus 18. So I might choose to do that over here. 21, 6, 18. Column addition, 7, 8 makes 15. Carry the 1. 2, 3, add the 1 makes 4. 45 units. Hang on a second then. We're dealing with area. All the units given were centimetres. So we are dealing with centimetres squared. Marvellous. Perimeter of this shape. Again, we've just seen one of these, but there's no squares to help us now. We can imagine this is a big rectangle going out across here, coming up here. Then this side length would be the same as this side length, so all of this would be 10. If all of this is 10 and this bit is 6, this bit would have to be 4 centimetres, because this bit would be 6 centimetres. By the same logic, all of this is 9, so all of this is 9. If this bit is 2, this bit would need to be 7, so this bit needs to be 7. So at least just by adding that onto the diagram, that's going to hopefully get you some method marks, if nothing else. Perimeter means all the way around the outside. So if I start here and I go, let's say clockwise, I suppose, following all of these lines all the way around, how far have I moved? I've gone 4 plus 7 plus 6 plus 2 plus 10 plus 9. Then I'll put all the way back to the beginning. Add that up using column addition. 6 and 4 makes 10. 7 and 2 makes 9, so we're at 19. Add another 9, gets us to 28. So it's 8 here, carry the 2. Only one there, 38. Our answer is 38 centimetres. Now this wasn't an area, it was a perimeter. That's a distance. So there's no need to say centimetres squared, because that would just be wrong. It's how many centimetres have you had to move to go all the way around the edge. Good. Alrighty. Bid mass. Got to be done. So, 10 times 3, 12 plus 30, final answer, 42. 5 times 6, 30. Still got the 8, still got the minus 2. 8 plus 30, 38, minus 2. Final answer, 36. Right, so in this one here, why did we do the 8 plus 30 first, not the minus 2? Well, because addition and subtraction have the same power, same hitting power, as it were. So we always work from left to right. Right, here we go, brackets. This one says 2 plus 2, which should be a 4 in a bracket there. Still got to do the squared. Minus 2, minus 2. Careful, this isn't two minuses right next to each other. This is saying start at minus 2 on the number line and take away another 2. So imagine here we are. Eek. Let's call that 0, 1, 2, minus 1, minus 2, minus 3, minus 4. Let's extend it even further over here. Right, starting at minus 2, that instruction. Start at minus 2, take away 2. Well, that takes me this way. So I'll end up at minus 4. So in this bracket here, we've got minus 4. Right, 4 squared, 4 times 4 is 16. Take away minus 4. Now we do have two minus signs right next to one another. This is saying subtract negative 4, which is the same as adding 4. Final answer being 20. Job done. Right, tiny bit of algebra here, tiny. I start with t, then I treble it. Done. 3 times t, or 3t. 3t is the answer you should give. I start with w, I then multiply it by 4, and then I subtract. Oh, good one. Subtract this answer from 40. Okay, so this isn't going to work as a methodology, but we know what w multiplied by 4 looks like. It looks like 4w. If I'm subtracting it from 40, it suggests I've already got 40, and I'm taking away 4w. Final answer, 40 minus 4w. Around 432 to the nearest 10. Right. The 10s are represented by this placeholder here. So to the nearest 10, the answer is 430. To the nearest 100, this is the 100 placeholder, units, tens, hundreds. So 6 is what I'm interested in. Does the 7 round up or round off? It rounds up. So it becomes 5,700. Now in both of these, I've maintained the size of the original number. It would be silly to round 432 to 43. It would be silly to round 5,673 to 57. So these zeros make sure that the size of the number is maintained. Alright, part C, 3 decimal places. Right, here's the decimal point. First decimal place, second decimal place, third decimal place. So this is the one I'm interested in. Does this round me up or off? It rounds off. So quite simply, 3, 7, 2, 3, completely unaffected. 2, 7, 2. Part D, round this one to 1 decimal place. Okay, going to get interesting. So the first decimal place, put it back in there, is this 9. What does this 8 do to it? Well, it rounds it up. But if 9 rounds up to 10, there's not enough room in this box to fit the number 10. So the 0 goes in here, and the 1 is added on to the next column up, because this is the column which represents 10 times bigger than this column. So it'll be our final answer of 66.0. Quite important to put 0. It tells us that we have rounded up from somewhere. Okay. Good. Estimation. We always estimate to one significant figure. So this is the first significant figure. It's the first non-zero number. What does the 8 do to it? Does it round it up or off? It rounds it up. So this needs to become 300. Again, I have to maintain the size. It'd be silly to estimate by rounding 287 to 3. That's not what's going on, it's 300. Multiplied by, this is 3.1212. Well, again, first significant figure is the 3. Does the 1 round up or round off? It rounds off. So that's 3. 300 times 3 is 900. Estimate, again, this one. First things first then, let's round this number to one significant figure. Now, just as a matter of interest, is that 0 significant? Answer is yes, because it's trapped by 2 non-zero numbers. That may or may not be useful in a second. Let's have a look. Where's the first non-zero number? There. That's the first significant figure, that 1. Does the 0 round up or round off? It rounds off. So actually my estimate, or my rounding to one significant figure becomes 10, which needs to be squared still. 10 squared is 100. Okay, well done. 20 minutes in, last bit of algebra, and then we'll stop the video for now. Simplify, as in gather together all the same things. Well, I've got 3x plus 2x, so that makes 5x. and I've got positive 6y, take away 4y, or sorry, subtract 4y. 6y minus 4y is 2y, so I've got those 5x's and I've got 2y's. Final answer, 5x plus 2y. Over here we've got some numbers and some variables. Can't mix these things together, okay? So I'm going to treat my numbers separately from the x's. But be careful, look, minus 3x is where I start, add on 7x. So like that number line we had earlier, minus 3, let's call that 0, let's call that 3. If I'm at minus 3 lots of x and I add on 7 lots of x, I'm going this way to a final answer of 4 lots of x. So altogether that gives me 4x, and then I've got my 6, from which I need to take away 1. 6 take away 1 is 5. Final answer, 4x plus 5. Part C, q multiplied by q multiplied by q. Right, if you write down this, you get it wrong. We remember, if I'm multiplying things together, this is when our laws of indices come in. This is q cubed. Careful not to make this mistake, please. Okay, and part D, for those of you with really good eyesight, yx is the same as xy. Remember, this says 4 times x times y. This says 3 times y times x. But you're all clever enough to know that the associative law of multiplication means that it doesn't matter which order we multiply these things in. So this effectively could say 4xy plus 3xy plus 2x minus y minus 5xy, couldn't it? It could just say that. But that would be just too easy. Then we look at it just like the others. I've got 4xy plus 3xy, and I'm going to take away 5xy. 4xy plus 3xy makes 7xy. Take away 5xy will give me a total of 2xy's. I've got a 2x. There's no other x's, so I'm going to add on 2x. And there's a y. There's no other y's just on their own, so that one has to be there as well. Final answer, 2xy plus 2x minus y. Okay, that's the end of these first 13 questions. Lucky for some, hopefully for you. See you in the next video.